Hey guys, I'm Syed, and I'm going to be talking to you about architecture and artificial intelligence. And by the way, I'm going to be touching on topics that we've already touched upon, so thanks guys, Taylor and Sam, for setting this up. So what is architecture, right? I'll give you the boring textbook definition. Architecture is the fundamental parts of an organization, how they relate to each other, and how they fit within the design principles and the environment that guide it. But the really nice way to describe what architecture is to tell you that there are three kinds of architecture. Architecture that meets its requirements, architecture that doesn't meet its requirements, and architecture that's built that meets its requirement, but you pissed off the architect while you were doing it, right? So can someone tell me, of all these objects here, which one was developed by an architect that was pissed off? Right? Pretty clear. So how do you identify good architecture, right? I've already sort of discussed this. It's architecture that basically meets the requirements. There are two types of things that we look at when we talk about architecture. We talk about functional requirements and non-functional requirements. And both of these examples have been touched on today, right? So self-driving car needs to be able to detect an obstacle on the road and stop. Great, that's a functional requirement. We need to be able to detect fraudulent credit card transactions. Functional requirement, great. What's a non-functional requirement? Car needs to stop before it hits the obstacle, right? Yep. Then there are things about stopping in time, analyzing, detecting stuff in time, and hitting the brakes. We need to detect a fraudulent credit card transaction in real time, not after the fact, the way it's usually done, right? Examples of non-functionals. So when you talk about systems that use machine learning and artificial intelligence, there are new things that come into play for non-functionals. Usually you have things like availability, you have things like security, all the ilities, right? They're all non-functional requirements. But when it comes to things like this, you start thinking about things like explainability. We've already touched upon this. There's a really nice quote by Ludwig Wittgenstein, a psychologist, that says, "The limits of my language mean the limits of my world. If I can't actually explain to you how my system works, we can't actually move forward with this system," especially in the world of finance and trading and healthcare. If I can't explain to you why I'm taking this decision, I can't take this decision, to be honest. I'll live with a worse outcome than with a better outcome if I can't explain to you why I'm making this decision. Retrainability, how quickly can you retrain your models? That's really, really important now, especially when companies do experiments in one language and the production is in a different language. So you train in R and Python, and then you say, well, now that it works, now let's redo it in Java and deploy it. But the model needs to go through these new steps in between every time you retrain the model, so that slows things down. Adaptability, and now we're starting to talk about things like, what's the variance within which you're willing to let this system run by itself and train itself? How many people here have heard of Microsoft Taybot? All right, a few of you. All right, so this was a robot that exceeded its adaptability by becoming racist and many, many, many bad things, all right? And they took it down and they put it back up, and in another 2 hours it became what it was again, racist. So here's an example of a Google car, right? And it sees something and stops. And my question to you is this example of good architecture or bad architecture?
Depends.
The perfect architect. You should be an architect, my friend. So this car sees a disabled person in their mobility scooter chasing her ducks. Okay, that's what the car sees. And it stops. And this actually is an example of good architecture, because what happened? It saw something, it didn't understand what it was, and it did the right thing. It stopped and waited. And at this point, the machine actually said, human, you take control. I've never seen this before. I'm not going to do anything. That's an example of good architecture. And what do I do for a living? Explainability is a relative term, right? So I draw diagrams like this all day long. This explainable, this not explainable. This done by a human, this done by a machine. That's it.